Okay, this is the M1 paper from January 2024. It's question number 5, and if we look at it, we can see this is going to be a moments question. Give you a little bit of time just to read through all the information, but we basically got a beam of mass 30 kilograms and length 3 meters. Tells me later on it's a uniform one, so I know where the mass is going to be acting on that one. Rests on those two supports with those lengths. A person of mass 55 is going to stand on the beam between C and D, so the person's going to stand somewhere around there. And it tells me CP is going to be equal to X, so it tells me just to make that length there X, and says, using the model, can we show that the magnitude of the reaction at C, that reaction there, is given by 686 minus 245 to the X. Okay, let's have a look at the diagram then. So I've just basically drawn out the frame of what we're going to have, and it told me this length was 0.4, it told me this length was 0.4, it says it's a uniform beam and that the weight is 30 G. So I start off by putting 1.1 here and 1.1 in there. I'd very much suggest when you're doing these in the exam, use a pencil to start off with, because we're going to keep adding to the information. Obviously, I'll have my reaction at one of the pivots and a reaction at the other pivot there, RC and RD to start off with. And then it says to me, okay, there's a person here which is going to weigh 55 G, and the question said set this length out to be X, and if that length is X, then this length left here is going to be 1.1 minus X. So I've got that as my sort of initial setup, and it says, can we find the reaction at C? So if I want to find the reaction at C, what I really need to do is to get rid of the reaction at D, and the easiest way to do that is to take moments at D, because then that reaction force won't be anything to worry about. So I'm going to take moments about D. So if I do that, what am I going to have? I'm going to have these two forces both acting together anti-clockwise, and I'm going to have this force acting on its own clockwise, but we know everything's in equilibrium, so all those things will balance out. So if I want to do that clockwise, then I'm going to have RC multiplied by this entire length here. What is that? Well, you could do it as this plus this plus this, but possibly an easier way of thinking about that is it's just the length of the rod, which is 3, minus 2 lots of 0.4. Either way, that length there is 2.2 meters. So that's going to be the same as 30G times 1.1 and 55G times that length, and that length is going to be 2.2 minus X. So let's just clear all that up for the examiner. That's going to work out to be 30G times 1.1 and 55G multiplied by that length there, which we said was 2.2 minus X. So the only thing we don't have there is, we want to rearrange, we want to get RC equals, so that's 2.2 RC is going to be equal to, well, that's 33G there, and that's going to be plus 110G minus 55GX. So if we tidy all that up, we get 2.2 RC works out to be 143G minus 55GX, and then RC is equal to that divided by 2.2, and sort out the G on that first one, that works out to be 686, and that works out to be 245X, which is what we wanted here, was given to us as our first part. Okay, so that's part A done. Part B then says, okay, the magnitude of the reaction at C is 4 times the magnitude of the reaction at D. can we find the value of x? Yeah, we absolutely can. Now, if I was doing this in the exam, I wouldn't keep redrawing out the diagram all the time. I might draw it out if I needed to for significant change. But here, because I'm explaining it to you guys, I can take a little bit longer. I'm not working under exam conditions here. So for my part B here, and obviously I can use the iPad so I can move things around quite nicely here. So what have they told me? They've told me then that this RC, I can call that 4RD now. Okay, so if I can do that, I'm going to call that 4RD. And it says, can we try and find what x is? Right, so if I want to try and find what x is, just have a think about planning this before you get started with the question. If I just try and take moments, doesn't matter where I take moments about. If I take moments about there, then I've got 4RD and RD involved. If I try and get rid of RD by taking moments about there, I've still got it over there. And it's similarly, if I try and take moments about there, I've still got 4RD over there. So there's no way of getting rid of my RD from my work. So the other thing that you must remember, we've got two sort of tools that we can use in our arsenal for doing these questions. One of them is taking moments, but the other one, I'm going to do it rather than just talking about it, is we can resolve vertically. And if we resolve vertically, what we're going to get is that the forces going up, 4RD plus RD, is equal to the forces going down, 55G plus 30G. Oh, brilliant. I can actually work out what RD is going to be from that because I've got 5RD works out to be 85G. So RD works out to be 17G. So now that I've got that, I'm not going to put it on my diagram. They're quite often, that I know what those two are now in terms of G's. Now what I can do is I can take moments because in effect, the only thing I don't have now is X. Okay, no matter what I'm going to try and do, I've got that value, 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 I've got that value up there. The only things I won't have is anything that's involved in terms of X. So I can take moments wherever I want now. Doesn't matter where you take moments. So I'm just going to try and use my common sense here and say, or just think that when they set it up, they said X was the distance there between the 55G and C. So just in terms of my algebra, it makes sense to me to take moments about about C. If I take moments about C, for example, I'm going to have that times that, which is a relatively easy thing to be able to do in terms of then tidying up all the algebra. So that's the reason why I'm choosing to do moments about C. So moments about C. And what have we got going on there? So if I'm taking moments about C, not worried about that one because there's a zero distance. I'm going to have these two going clockwise are going to be opposed by this one going anti-clockwise. But as I say, we've got pretty much everything we need in there. So if I'm going to do that, I'm going to get 55G multiplied by X plus 30G multiplied by, that was 1.1 from our original question, remember, is going to be equal, it's going to be equal to 17G multiplied, 17G because it's RD, and we know that RD is 17G, multiplied by, and again, remember, we've already done that length previously in the question, multiplied by 2.2. So tidying that all up, what's that going to give me? We're going to get 55GX plus 33G is equal to, what's that, 1734, 37.4 G. You can cancel the G's, or they can go when you divide them all out. X works out to be, I'm not going to bother doing this, you can do it all, 37.4 minus 33, well, let's write that out, I suppose, 37.4 minus 33, all divided by 55, and apparently that works out to be 0.08. So 0.08 meters. Find the value of X. Yeah, it didn't say anything about decimal places or significant figures when we were doing it. And then on to the last part. It says, person steps off the beam and places a package of mass M at A. Package is modelled as a particle at a point. Yeah, that's okay. Beam is now on the point of tilting about C. See if we can find what M is. Right, so I certainly, even if I hadn't redrawn out the diagram for the first bit, I would definitely be drawing out this diagram for the last part here. So give me a few seconds just to work out what I do have on here. So in this situation, the person's gone now. So I can put that information back as 1.1 there. And then what they do is they're attaching something here with a mass of mg like that. And what they're saying is that this is on the point of tilting about, oops, it's on the point of tilting, sorry, I just want to, this is to explain it to you, is on the point of tilting about C. So what we're saying with this then is that if we have this situation, this object is going to be doing something like that. It's not quite like that, but it's on the points of actually tilting round there, of it going round and something like that. So think about what's happening at RD then. When this is on the point of doing that, the RD will work out to be equal to 0. Now, the first time you got told that would have been a surprise to you, but you should have seen this through many questions that we do. It's a really good way for the examiner to get rid of one of our variables here. So I'm going to explain to the examiner what I'm going to do, what I'm about to say. So on the point of tilting about C means RD is going to be equal to 0. And I'm not going to get rid of RD, I'm just going to put RD equals 0 there. Right, once that happens, then this is a really quick question now. And again, I would urge you to plan what you're going to do before you actually start the question here. So yes, I could do that plus that is equal to that plus that. Not really going to be too much help to me here. It's much simpler to just say, if I take moments about C, and I'm choosing to take moments about C because then RC disappears out of my equations here, all I've got is this one times this one is this one times this one. And the only thing missing there is M. I've got all my other values here. I don't need to worry about my RD over there because we've just said it's on the point of tilting, which means that RD is equal to 0. So here, really, really quick with this last part, I can just say moments about C now. So if I take my moments about C, I'm going to get 0.4 times mg is equal to 1.1 times 30g, and say the only thing we don't have there is m. So the g's can cancel. M is going to be, what's that, 30 times 1.1 divided by 0.4, and then whatever that works to as an answer, 82.5 kilograms. Let's call it 83 kilograms. We'll do it to two significant figures because we've had G floating around in our question. And just check, yeah, it doesn't say anything about decimal places or significant figures anyway. So, yeah, that's the question number 5. Relatively straightforward. Lots of different techniques that we use all the time there. So a good one for you to keep looking at. Hopefully that makes sense to you all.